Awesome. Well, great to meet you, everyone. My name is Vinayak, co-founder and co-CEO of Ikigai. We're an enterprise AI platform out of MIT, particularly focused on time series data, and excited to tell you more about what we're up to. So today, I really want to cover two things. One is why you should care about time series, and two, how you can use the Ikigai platform to work with time series to enable AI solutions in the enterprise. So there's obviously no shortage of AI use cases. That's why we're all here today in this room. We're trying to solve as many business problems as we can to drive value for our respective organizations. However, 85% of AI solutions end up not actually gaining any adoption. How many times have you worked really hard on a model, deployed it, only for the business not to actually take full advantage of it? The AI solutions really face two classes of challenges. On the technical and data side, challenges on the technical and data side related to building it, and then challenges on the organizational and people side related to adoption. So, on the technical side, most enterprise data is tabular. It comes from systems like Salesforce and SAP. One of our key realizations was that a lot of this data, the majority of this data and their associated business processes are actually time series. However, there aren't very good tools to work with time series. So if we could actually make it easier to work with time series, we could unlock a large portion of business use cases. Second, on the organizational and people side, it's really not enough to just deploy a model. In order to drive adoption, the model needs to be easily, or the solution or model needs to be easily consumable, explainable, and easy for experts to edit. So if we could appify our models to have these properties, so think more ChatGPT, not a model like GPT-3, we could boost enterprise adoption of our AI solutions. So first, I want to talk a little bit more on the technical side and our approach to dealing with time series. And then I'll talk about how you can actually use the Ikigai platform to actually build solutions to build apps on top of that to drive enterprise adoption. So time series are notoriously difficult to deal with. And there's a huge gap in AI solutions that can actually help you work with them. So for example, with time series, you're typically dealing with constantly changing trends, seasonality. You're dealing with multiple levels of scale or hierarchy. So think you have to build models for daily forecast, weekly forecast, monthly, annual. If you're in supply chain or sales, you might have to build different models for SKUs, store level, region level, country level. And then finally, on top of this, most of the time you have very limited or sparse data. All these problems get amplified when you're actually dealing with multiple time series, which is often the case in many of these business contexts. So I want to talk a little bit about Ikigai's approach to dealing with time series. We use something called LGMs, or Large Graphical Models. So graphical models have been around for over 100 years and have several applications in machine learning, physics, communication. They are extremely good at efficient model learning on top of sparse data. In fact, most of you here today have a graphical model or several graphical models running on your phones right now. So there's two key breakthroughs in graphical models that led to Ikigai. First was domain agnostic learning for graphical models, and second was doing so scalably. So with domain agnostic learning, we can efficiently learn the model on top of any sort of tabular data. In the particular case of time series, what we're really doing is efficiently learning the optimal joint distribution across all regions of the single time series and then across all regions of multiple time series to build a model. And that's what graphical models let us do when we have limited data or constantly changing data like time series. So now how do we actually put this into practice? So it's great to have LGMs, but the part of the Ikigai platform is to really help you do two things. One is utilize those LGMs to build time series models and work with time series. And second, turn them into apps so that your business users can actually use them. So to work with time series, what we've done at Ikigai is built 3 main models. So they're called AI Match, AI Cast, and AI Plan. What AI Match does is AI-powered joining or reconciliation of data sets. So this is extremely useful when you have multiple data sources coming in from disparate systems, potentially even with different schemas. So we use AI to learn mappings between the schemas as well as look at other properties of the data sets like underlying distributions to actually suggest how you match those. AI Cast is, you can think of it as our take on AutoML for time series, and AI Plan is AI-powered scenario analysis. And behind the scenes, we handle everything like connecting to data, scaling compute, and deploying your models. Then finally on top is the no-code layer where you can actually build these apps for experts to interact with, edit the models, and surface explainable insights. So going into AI Match, like I mentioned, it's AI-powered joining of data sets, especially when you have multiple time series. This becomes extremely important. So like I mentioned, what's going on behind the scenes is we're using graphical models to learn models of both of them, and then using both the data properties like values in the schema as well as the underlying probabilistic distributions to actually figure out the best matches for these data sets. So that's what's going on behind the scenes, and then so here, what a user might actually see is how we're matching the data sets, and then as an expert, they can say, approve certain matches, or if there's anything that we can't match, they can actually go in and tell the system how to match it, and then AI Match learns from that and in order to improve its matching model as data keeps coming in and changing. On the AI Cast, like I mentioned, this is like AutoML for time series. So what you do is you just feed in your time series data. Hopefully, you have data coming from multiple sources. You might have used AI Match to actually combine them. Now you have either a single or multiple time series. AI Cast goes in and actually figures out the best time series model. We have ours behind the scenes, as well as all of the usual models like profit and so on. And it might actually figure out different models are better for predicting at different scales or certain types of items. And then we also handle all sorts of details behind the scenes, like things like hierarchical reconciliation. So making sure that, again, if going back to the sales example, that all of your SKU sales add up to your store sales, which add up to your regional sales, and vice versa. And again, this is all expert in the loop enabled. So this is an example of kind of the app interface that the business user might see on the front end, and they can actually go in and adjust values. An example being, the last 2 years you were running a promotion on Labor Day. This year you decided not to run a promotion. That's not going to be reflected in the data. So the end user, like for example, a demand planner can go in and adjust that value. And then finally is AI Plan. So after you create a forecast, you might want to generate different scenarios on how you achieve a particular target. So what AI Plan does is uses reinforcement learning to generate different simulations or policies based on top of the forecast and creates all of these different scenarios. So in this example, this is what an end business user might see. Each dot here is a different scenario showing a trade-off in this example between revenue made and maybe inventory on hand. So you can actually choose which policy you want, and then it'll go in and actually, based on the simulation, tell you what you need to order. So again, an expert can go in and play around with different policies and run different what-if scenarios. So a key aspect is it's not just about building the models behind the scenes. We put a lot of horsepower into dealing with the time series data, but also how do you drive adoption and usage for the end business user. So every single app that you build in Ikigai is expert in the loop enabled. We surface explainable insights for all of our models, and we allow you to actually integrate it into your enterprise workflows, connect to all of your data sources, easily deploy it. So I would like to leave you guys with a couple of things. First, hopefully I've convinced you that most business problems are actually time series problems, and this is an area to pay attention to. And finally, to really drive adoption of these solutions, we need to go beyond models to apps that are easy to use, explainable, and incorporate experts in the loop. If you'd like to learn more, please get in touch with us. You can email me, Vinayak at ikigailabs.io, or reach out on our website. And I think also if we have some extra time, I'd love to take any questions as well.
you explained that you built in support for a particular kind of time series, which is sparse. And you also said that the time frames you're doing forecasts for start at the maybe day or weekly level. So I was wondering whether you have already capacity or planning to implement features for time series of a quite different type that are not sparse and where a forecast is required for, let's say, the next half hour to the next 2 hours. For example, for sensor data, for monitoring machines, or even physiologic data.
That's a great question. Thank you. So, in terms of the Ikigai platform, we can handle even more granular data sources. It's basically that would require just more compute, which we will automatically scale behind the scenes. So, one example, which might be related, is for a large chemical manufacturer. They're using our AI cast they want to figure out before a process finishes whether that process is manufacturing process is going to fail or not. So they're collecting data by the second, effectively. The more data, the better. And then on the flip side, if you don't have much data, for example, maybe you're launching a new product or you have a new process where data might be a little bit more sparse, we can actually use other data sets as effectively what happens behind the scenes, use other data sets as a reference to fill in the sparse data. So in that particular case I was referring to, they're collecting data by the second, and we were able to predict within 30 minutes of a process starting whether it's going to fail before the whole thing runs. So it's a great question.
Hi. Wow. Okay. Yeah, I was just wondering if you were able to handle estimating demand for large-scale systems where you have like a long tail and huge amount of zeros.
Speaking of sparse systems.
Two. Yeah, great question. So in the particular case for e-commerce or retail, a couple of scenarios we see related to that is one, new product launches, so you don't have much data about it or very limited data. These specialty items, maybe promotions, and discontinued items as well pop up quite a bit. So in those cases, yes, we are able to. Basically what we do is, the way it works is we'll look at similar items. So part of what the large graphical model is doing is, you can think of it as taking your time series, whatever data you have, and then chopping it up into a bunch of different sections. And then we look at all the other time series you have. So for example, in the SKU case, say you have this commemorative pen. We will look at the data, chop it up, and then compare every region that's been chopped up to every other region of every other SKU, and then try to identify which SKUs or set of SKUs resemble that the best. And then what we do is actually put all of that back together. So even if you have limited data for this one commemorative pen, we, behind the scenes, the LGM has seen that, hey, it actually has properties. It's 30% similar to a blue pen, 40% similar to some other item, and then 30% similar to this other item. And then using those relations, that's how we can kind of fill in the sparse data. And then, of course, it's never perfect, I'll admit that. So the expert can go in and actually say, hey, actually, that's too high, let's lower it a little bit. Yeah. Awesome. All right, thank you, everyone.